Over the past couple of days, we have talked about things like El Nino and La Nina, which can cause hurricanes, especially La Nina can cause an active hurricane in the Atlantic Ocean. We talked about how hurricanes needed warm water, and we talked about how when the hurricanes get to go over that Gulf Stream, or if they even go into the Gulf of Mexico, that's a big body of a large body of warm water that can really give them a lot of energy. We compared it to like drinking a Red Bull right before it comes on land. Kind of true, gives a little bit more energy. So today we're going to dive a little bit deeper into hurricanes. So what is a hurricane? Well, I don't think that this is a huge shock to anybody. I think you all have a pretty good understanding of what hurricanes are. You've seen them on TV. You've had them blow through. We've seen it where we were out of school here. Even here, we're not even on the coast, and we were out of school here for about a week thanks to hurricanes knocking out power and flooding the schools and things. But it is a massive storm. And it's so massive, as you see here, it can be 600 miles across. And the winds can be very, very light. When I say light, 75 mile an hour winds is definitely not a light wind. But compared to 200 miles an hour, 75 is really nothing. Hurricanes can last weeks, like at least over a week. They move about 10 to 20 miles an hour, as you can see right here. Sometimes faster, sometimes a little bit slower. I like it when they're a little bit slower and they don't get a chance to ever make it to land. They just kind of die out at some point in the ocean, which is a good thing. We know, again, right here, evaporation from seawater increases their power. How we're going to have evaporation from seawater? If the oceans are warm. And when you have that evaporation, you have that condensation, you have the hurricanes starting to bring more and more water inland with the rains that they have. You don't need to know about it rotating counterclockwise at the eye in the northern hemisphere and clockwise in the southern hemisphere. It does that because of the Coriolis effect. That's something that we can get into later if we get some time. We do need to know that the eye, the middle of the hurricane, is the calmest part. It has the lightest winds, and you can actually kind of see clear blue skies if you're looking up above that. However, hurricanes can be extremely dangerous and cause massive damage. They form over warm ocean water. Now, we have said this, maybe 25 times at this point. If you don't think that that's a question that's not going to show up somewhere, you are wrong. You need to have that warm, humid air above the ocean in order for hurricanes to form. Now, we know when you have warm air, what does warm air do? Warm air rises. Now, if warm air starts to rise, that causes a low pressure in that area. And when there's a low pressure in that area, other air gets kind of sucked into that area. It's pulled in because air moves from high pressure to low pressure. And when it does, that air becomes warm and humid, and it rises up into the sky as well. And you keep having this, again, that's kind of like a convection cell. You have that convection cell that keeps going, and you start forming these bigger and bigger clouds. And because of the Coriolis effect, they start to get this turn, this spin to them. It may start out as like a tropical storm. You hear that very often, a tropical storm. But if it builds up enough force and it builds up enough energy, it becomes a hurricane. More and more warm water continues to give energy to the hurricanes. Understanding that they form between 5 to 15 degrees latitude north and south of the equator, that's okay. Understanding that they're not going to form at the equator is kind of important. That's because there's really, remember, not a lot of winds there. We're in the doldrums at that point. They're too weak. Hurricanes are too weak. They don't really form at the equator, which is a good thing because you would think, ooh, Mr. Bullens, the equator, super hot all the time, hot water, tons of hurricanes. Luckily, it doesn't work out that way because of all of that just constant updraft, and they really don't have a lot of winds to move anything there. Very fortunately, a lot of our hurricanes never make it into land. They just stay out over the warm water. They dump all of their energy back into the ocean, and they kind of just die out. But as we've seen, especially in La Nina years when it's a more active hurricane season in the Atlantic, you can have hurricanes move onto land, and that can be extremely dangerous. And here's the reason why. Not only do you have tons and tons and tons of water, lots of precipitation moving in with the hurricanes, you also have super strong winds. Now listen, we've seen here recently that just having tons and tons of rain and some fairly strong winds just starts to blow trees all over the place, and people start to lose power. Multiply a fairly strong wind to something where it's like 320 kilometers per hour. Now you're really starting to see a massive difference. You're starting to see extreme damage, like buildings are gone, trees are not even blown down, they're gone, like they're not even in the same place anymore. Cars blown over and toppled. When you have that ton of water being dumped down at the same time with the rain and those strong winds, it causes a lot of damage. But that's not the only thing that happens. Maybe one of the most dangerous things about hurricanes is something called the storm surge. The storm surge. So as these hurricanes are turning and twirling and they're moving along in the ocean, they start to kind of gather up a little bit of extra water with them in the ocean as they're moving in. And as it moves into land, all that water that's kind of pulled up into that area with all of that circulation is pulled into the land. And you have something called a storm surge. And you can watch that on these videos. I'm pretty certain I added some stuff in there. I would say that storm surges are very often the most devastating part of a hurricane. Yes, the winds are very bad and they can be very damaging. Yes, the rain can be very damaging. But the storm surge is when it pulls in this ton of ocean water and it just starts flooding the coast. And you've seen this, and I actually have some videos of storm surge. I think I have 2 videos attached for you as well, of how storm surges just come into the land and it just starts to flood everything. And flooding is extremely dangerous because it doesn't give you an opportunity to go anywhere. You can't if you don't evacuate when they give the evacuation orders, you can't see the storm surge coming and then think, oh, I'm going to go outrun this. There's enough videos out there of people trying to get into fast-moving water, and water will take you quickly. People try to outrun it in their cars. That's not going to work out if you don't listen and leave when you're supposed to. And then you can end up getting trapped. And I'll have to find the video. I'm still looking for the video of those people that were trapped in that hotel. I'll try to play that for you this week. But it's amazing to see just how much damage the storm surge can cause. A hurricane will cause more storm surge in areas where the ocean floor slopes gradually. And that's kind of like what you see on most of our coast. Not all of our coast, but most of the coast of North Carolina. And let's see if we can take a kind of a look at that. Whoops, that's not what I wanted to do. Give me a second. So here's some things that you might see at a beach. So you've got kind of 2 different kind of beaches. You have some beaches where you walk out and it slowly starts to slope off. And then over here is where, obviously, like the ocean is all in this area. This is your gradual slope. And this is pretty much what I see at the beach most of the time when I go to the coast of North Carolina, in most places. You have this gradual slope where you can walk and it starts to get deeper and deeper the further out you go. There are some places that I have been. This is more when I was on the West Coast. When you go out into the ocean, it literally is, whoops, that's the wrong color. It's like this. And it just drops off. And I'm not joking. It just drops off. Like you are walking in water and you have some sand under you, and then it's like it's over your head in like no time. It's kind of wild how this happens, but you can kind of see how the storm surge would have a little bit easier time coming on land. Here, it's just going to keep coming up and over. Here, it would have to come up and make it over this, but this kind of wall is going to stop some of that from getting to the land, and it wouldn't cause as much major flooding. Although if it's a big enough storm surge, it's going to make it over both of those types of land anyway. But it's when you have that gradual slope that you have more flooding. And we've seen this very, very often. And any of the folks in here that end up going to Oak Island, you know that anytime it could just be like a bad enough storm to bring in some of the ocean, it washes up on the shore pretty bad. But if there's a hurricane there, the front streets are flooded for at least a week because of the storm surge coming up and over, because there's really not a huge amount of sand dunes, and there's a gradual slope as you walk out of the ocean. It just helps bring in more and more water when that happens. Again, hurricanes form in those warm waters. They might form near the equator, might be a little bit up, a little bit up further than that, because again, they're not going to happen at the equator because of all of those updrafts. They need warm water. Okay, just kind of a review here. Hurricanes rotate in a circular center called the eye. Here's a video that you can watch about hurricanes. The most dangerous part of the hurricane with the strongest winds happens to be the eye wall. So you can see here's the eye of the hurricane. It's this part right here, right outside. So I know that you can see blue skies when you're in the eye, but the eye is only a few miles wide, and you know that as soon as that passes you, you've already been hit with one part of the hurricane, the front side and part of the wall, and you're about to get hit with it again. So a lot of times people think, ooh, things are better because they get into the eye of the hurricane, not understanding that the backside of that you're going to get hit again with some of the strongest winds, the thickest clouds, and the heaviest rain, and that's very, very dangerous. When a hurricane reaches land, it often produces this storm surge. We have a whole page about this storm surge, which is extremely important. High winds push the ocean towards the shore. Again, you have all of that water moving in, causing flooding into the areas. Now, this part's not on the test. It is extremely interesting, though. Have you ever wondered how these hurricanes get their name? How do hurricanes get their names? Well, it comes from the World Meteorological Organization, the WMO. I think I'll start calling it that because it's a whole lot easier to say. And each year, the tropical storms are named in alphabetical order, and there's a list given to them. So there's a list like A through Z, and they probably have some even more after that. And so they name the storms. So let's just say there happened to be a storm named Hurricane Reagan, and it went through, and we all know that's going to cause massive damage, right? That's going to be lots of flooding, lots of damage, because Hurricane Reagan would just terrorize everything. And here's what would happen. You wouldn't be able to use that name until 6 years later. They kind of go through these lists of names. It's very interesting. I'm sure if we were to look this up, we could probably find the names of how they're going to name the storms this year and already have the list looking at it. Maybe we can do that in class later on this week. So listen up. This week's a little bit different. I'm not going to give you a quiz on the other side of this. You have one small thing that you need to do. You need to access the Nearpod slides. When you get to these slides, I believe it is going to be this slide right here. So you'll be able to use this slide here. Let's see here. I don't know if it's going to let me necessarily do that because I'm not you. But again, here's a map. Here's the Atlantic Ocean. What I want you to do is I want you to create a hurricane, draw it, name the hurricane, describe some things, some situations that might make your hurricane stronger. I want you to talk about not just one thing, all of the things about a hurricane that would be dangerous, especially what you think would be the most devastating part. And I think that that's definitely up for debate. If you want to argue about what the most devastating part of a hurricane is, I don't think that there's a wrong answer to that. I know in our notes, I put there's something that was listed as the most devastating element, but again, that's up to you. So enjoy doing that. Hope you have a good day. Again, make sure you access those Nearpod slides, because if you don't, then you're going to miss out on this part of the assignment. And I will see you later. Bye.